All right, so this video is going to cover our Test 4 notes packet, just Module 7 Homework 1 though. So rational functions and expressions. So that word rational is just a fancy word for saying fraction. So fraction functions and expressions. So we're dealing with fractions, which we dealt with fractions in the past, but kind of bringing back. Test 4 is really good about going back to Test 1 and kind of re-loop in there and adding on stuff that we've learned throughout the semester. So in this section, we're going to identify, simplify, multiply, and divide rational expressions. So expressions with fractions in them. So a little fraction review. So simplifying 0 divided by 5, 0 over 5. Remember, fractions mean divide. So 0 divided by 5 will give us 0. Whereas to simplify 3 over 0, so 3 divided by 0 will give us in our calculator an error. We cannot divide by 0. So it says error, which in this course we're going to label as DNE, which means does not exist. So does not exist. And that's because we cannot divide by 0. So going back to properties of divisions, we cannot divide by 0. Let me get a marker too right now. So cannot divide by 0. Next, if we have to simplify 6 over 18, 6 divided by 18. So a couple ways we can go about this. Looking at 6 and 18, what is the GCF? What do they have in common? Well, they both have in common a 6, so I can factor or divide out a 6 from the top and the bottom, which would be our GCF. And we're left over with up top 6 divided by 6, which is 1. On the bottom, 18 divided by 6, which is 3. So 1/3. Another way we can look at it, so or, if we have 6 over 18, 6 is the same thing as saying 6 times 1, divided by 18, which is the same thing as saying 6 times 3. That way my 6 divided by 6 goes to 1, they cancel out. So cancel out like factors. They both have that factor of 6 in common, so I can cancel it out, and I'm left over with 1/3. Because this is kind of how we're going to be doing the next one, which we'll see in a second. But either way, it doesn't matter, you still get to 1/3. So by definition, a rational expression can be written as a quotient of P over Q of two polynomials. Again, remember, rational expression, that word rational means a fraction. Be written as a quotient. Quotient means to divide. Of P divided by 2 of two polynomials. So simplify the lowest terms, if possible, 18W divided by 81W. So 18W divided by 81W. Let me rewrite it. So 18W divided by 81W. Again, multiple ways we can kind of think about this, but thinking about it in a GCF way, kind of like we did this one here. So looking at 18W and 81W, they both are divisible by 9, so we'll have a 9 in common, and they both have a W in common. So it's kind of like our GCF. We can factor or divide out our GCF of 9W from the top and from the bottom. And that would give us 18W divided by 9W, which would give us 2, all over 18W divided by 9W, which would give you 9. So 2 over 9. Nothing that 2 and 9 have in common, so I cannot simplify it further. Done. Same thing, or if we write it in factored form, like we did on this one up here, if we have 18W divided by 81W, 18W, we know 18 is 9 times 2 times our W, all over 81 is 9 times 9 times our W. And let's see what factors cancel out. Our 9s cancel and our W's cancel. So we're left over with 2 up top, 9 on the bottom. So 2 over 9. Again, there's nothing that 2 and 9 have in common. So that's our final answer. So thinking of the same thing, let's simplify the expression 4y to the 4th all over xy, 4y to the 4th all over xy minus 8y. So looking at this, I want to write it in factored form. So up top, 4y to the fourth. So that's really like 4 times y times y times y times y all over xy minus 8y. So GCF, they both have a y in common. So let's factor or divide out that y. And in doing so, we're left over with, taking out the y, we just have x, negative 8y. So taking out the y, we're just left over with negative 8. So I factored out the y, and we're left over with y minus 8. So now let's see what factors can cancel. So there's a y up top, y on the bottom, so those cancel. Nothing else is in common, so I can't cancel. So we're left over with 4 times y times y times y, which is y cubed, y to the third power, all over x minus 8. Now notice, even though these 4 and 8s have factors in common, they're not the same factor. This x minus 8 is a whole factor, notice in parentheses here, so I can't separate that. It has to be the whole factor that's the same. So because it's x minus, I can't break this up, so that means these are not like terms, so I cannot simplify that. So it's going to be our final answer, 4y cubed all over x minus 8. So notice we're going to cancel, let me use another color here. Cancel like factors. Same thing we did here. We canceled our factors. Same thing here. We canceled our factors. So we can cancel our like factors. Alrighty, let's keep going. So on the next page, it says, to simplify the following expression completely, 5x minus 45 all over x squared minus 8x minus 9. Again, like the previous page, we want to cancel our like factors. But in order to cancel factors, we need to put it in factored form. So looking just at the top, looking at 5x minus 45, our GCF here would be 5. So factoring out that GCF of 5, we're left over with x minus 9. So 5 times x minus 9, you put it in factored form, all over x squared minus 8x minus 9. Let's factor that. So x squared minus 8x minus 9, let's come down here. X squared minus 8x minus 9. There's no GCF to factor out. It is in standard form. We're going to factor this, by the way, just like we did on the last test. So it's in standard form of ax squared plus bx plus c. So a in front of x squared is positive 1, b in front of x is negative 8, c out by itself is negative 9. So we're looking for two numbers that multiply together to give us a times c, and the same two numbers to add together to give us b. A times c, 1 times negative 9, which is negative 9, and add together to give us b, which is negative 8. So negative 9 times positive 1 is negative 9. Negative 9 plus 1 is negative 8. Thankfully, our a value is 1, so we're able to use a shortcut and go straight to our two factors. Our variable's x, and our blank is negative 9, so x minus 9 is one factor, and our other blank is positive 1, so x plus 1 is our other factor. So we factored this, x squared minus 8x minus 9, my paper's sticking, sorry, to x minus 9 times x plus 1. Put it in factored form. So now we can see, okay, now that it's in factored form, what factors cancel? Well, I have x minus 9 on the top and on the bottom, so those cancel. No other like factors, so nothing else cancels. And we're left over with 5 over x plus 1. 5 over x plus 1. And that's our final answer. No like factors, so nothing else cancels. We're done. All right, next example. If you need to pause it, go ahead and pause it. But let's go ahead and go to the next one. So simplify the following expression completely. 3x squared plus 5x plus 2 all over 3x squared minus 10x minus 8. Let's go ahead and put this in factored form. So down here, let's factor. We have 3x squared plus 5x plus 2. Thankfully, this is in standard form of ax squared plus bx plus c. So a in front of x squared is 3, b in front of x is positive 5, c out by itself is 2. So I'm looking for two numbers that multiply together to give me a times c, and the same two numbers that add together to give me b. So a times c, so 3 times 2, which is 6, and add together to give me b, which is 5. So 2 times 3 is 6, and 2 plus 3 is 5. Unfortunately, our a value is 3, so a is not 1, so we must factor by grouping. Which means we're going to use the numbers in our blanks to split up this middle term, to split up 5x, so that way we can have 4 terms, so I can group the first 2, group the last 2. So 3x squared is going to stay the same. Instead of our 5x, we're going to use the numbers in our blanks, so positive 2x, positive 3x, and then plus 2. Now we have 4 terms, so I can group the first 2, group the last 2. Looking at my first 2 terms, 3x squared plus 3x, so GCF, they both have an x in common. So let's factor or divide out that GCF of x. That GCF of x is coming out front. We're left over with 3x plus 2. Looking at our next 2 terms, it's another 3x plus 2. I have to take out something. I want 3x plus 2 to be left over. So GCF, let's take out a positive 1. So taking out a positive 1, we're left over with 3x plus 2 again. So we know we did it right because they both have 3x plus 2 in common, so that will be one factor. Taking that out, we're left over with our other factor of x plus 1. So as you can see, factoring is super important. We're going to factor a lot. So if you still, after last test, don't feel comfortable factoring, please work on it. Please email me to let me know. Go to the tutoring center. We have so many different options. There's tons of videos. Even if you don't like it this way, go to YouTube and find something that works for you to help you factor. All right, so the first up top, 3x squared plus 5x plus 2 factored down into x plus 1 times 3x plus 2. So up here at the top, I'm going to rewrite this in factored form of 3x plus 2 times x plus 1. On the bottom, we have 3x squared minus 10x minus 8. So we can do the same thing. Let's factor this one. This is in standard form, so I have ax squared plus bx plus c. So a in front of x squared is 3, b in front of x is negative 10, c out by itself is negative 8. So we're looking for two numbers that multiply together to give us a times c. So 3 times negative 8, which will give us negative 24. And the same two numbers to add together to give me b, which is negative 10. 6 and 4. But they have to have different signs in order to multiply together to give me negative 24, so that's not going to work. So about 12 and 2. So let's see, negative 12 times positive 2 is negative 24. Negative 12 plus 2 would give us negative 10, so that works. Unfortunately, our a value is positive 3 again, so a value is not 1. So we must factor by grouping. No shortcut, unfortunately. So that means we're going to use the numbers in our blanks to split up this middle b term, so to split up negative 10x. So 3x squared is going to stay the same. Instead of negative 10x, we're going to use the numbers in our blanks, so negative 12x, positive 2x, minus 8. So now we have 4 terms. So now I can group the first 2, group the last 2. Looking at our first 2, 3x squared plus 12x GCF, they both have a 3 and an x in common, so 3x. So that 3x is coming out front. We're left over with x minus 4. Looking at our next 2 terms, 2x minus 8 GCF, they both have a 2 in common. So bringing out that positive 2 as our GCF, we're left over with x minus 4. We know we did it right because they both have x minus 4 in common, so that will be one factor. Our other factor, whenever we take those out, is going to be 3x plus 2. So we factored this one completely. So on the bottom, instead of 3x squared minus 10x minus 8, we're going to put it in factored form of x minus 4 times 3x plus 2. So now it's in factored form. Now we can see what factors are on the top and the bottom to cancel out. Well, on the top and the bottom, we have 3x plus 2, so those factors cancel. Up top, we're left over with x plus 1 as one factor. On the bottom, we're left over with x minus 4 as another factor. Notice I can't cancel out my x's because they're part of the whole factor. I can only cancel out the whole factor. This plus sign is linking the x and the 1 together. This minus sign is linking the x and the 4 together. These are not the exact same factors. That means I cannot simplify it further. Done. X plus 1 over x minus 4. So now down here, notice we can only cancel factors. You can only cancel the whole factor. All right, let's look at the next page. This is all about simplifying. We're going to continue to simplify every single problem, but let's add a little bit to it. So now we're going to multiply. So multiplying rational expressions, so we're going to multiply fractions. So before we do that, let's kind of go back as a little refresher and let's multiply and simplify just regular fractions before we get into crazy fractions. So if I have 1/4 times 2/3, whenever you're multiplying fractions, we are going to multiply straight across. Multiply straight across. So multiplying straight across. So 1 times 2 is 2. We have 1/4 times 2/3. So multiplying straight across. So 1 times 2 is 2. On the bottom, 4 times 3 would give us 12. So I have 2 over 12. So now it's just like the previous part of now we need to simplify. So looking at 2 and 12, they both have a GCF of 2 in common. So I can factor or divide out a 2 from the top and the bottom. That would leave us with 1 over 6, which does not have any factors in common, so we're done. Or if you like the way of factoring out, canceling out factors, said that backwards, so 2 out of 12, I can write this in factored form of 2 times 1, divided by in factored form 2 times 6. That way our factors of 2 cancel out, and we're just left over with 1 over 6. Either way, you still get 1/6. So however you like to simplify, you do you. All right, so let's simplify the following expression. W squared minus 49 all over W squared minus 3W minus 70 times W squared minus W minus 90 all over W squared minus 16W plus 63. So we have 4 different expressions. We're going to factor all 4 of them separately and then put it all together and see what whatever factors cancel. So it's really important to be super organized here. So down on the bottom, I'm going to go ahead and factor. W squared minus 49. So looking at W squared minus 49, our first step in factoring every single time is GCF, but there's nothing that W squared minus 49 have in common, so no GCF. I do notice is a difference of perfect squares. We are subtracting 2 perfect squares. So difference of perfect squares. So going back to test 3, so that means we're going to have 2 factors. W squared we know is W times W. 1's positive, 1's negative. 49 is 7 times 7. So we factored W squared minus 49 into W plus 7 times W minus 7. I'm just going to put it up there so that way I stay organized. All right, so next one. Again, saying super organized. Let's factor. Let's go across. So W squared minus w minus 90. Thankfully, this is in standard form of ax squared plus bx plus c. So a in front of, oh, by the way, there's no GCF. No GCF. But a in front of x squared is positive 1, b in front of x is negative 1, c out by itself is negative 90. So we're looking for two numbers that multiply together to give us a times c, and the same two numbers to add together to give us b. So a times c, so 1 times negative 90, which is negative 90, and add together to give us b, which is negative 1. So I'm thinking 10 and 9. So negative 10 times positive 9 is negative 90. Negative 10 plus 9 would give us negative 1. Thankfully, our a value is 1 here, so we can use our shortcut to go straight to our two factors. Our variable's w, and our blank is negative 10, so w minus 10 is one factor, and our other blank is positive 9. So w plus 9 is our other factor. No GCF to bring down, so we're done. So this one, w squared minus w minus 9, factored down into w minus 10 times w plus 9. Right here. All right, now let's factor w squared minus 3w minus 70. I'm going to move my paper up so we can have more room. All right, so this is going to be to factor w squared minus 3w minus 70. Thankfully, this is in standard form for us. So ax squared plus bx plus c. There is no GCF starting off. Nothing that all three terms have in common. So a in front of w squared is 1. B in front of w is negative 3. C out by itself is negative 70. We're looking for two numbers that multiply together to give us a times c. So 1 times negative 70, which is negative 70. And the same two numbers to add together to give us b, which is negative 3. So I'm thinking 7 and 3, so negative 7, no, to give me negative 3, 7 and 10. So negative 10, positive 7 would give us negative 70. Negative 10 plus positive 7 would give us negative 3. Thankfully, our a value is 1, so we can use our shortcut. So we go straight to our two factors. Our variable is w, and our first blank is minus 10, so w minus 10 is our first factor, and our other blank is positive 7, so w plus 7 is our other factor. So we factored it. There was no GCF to bring down, nothing. So we're going to rewrite w squared minus 3w minus 70 in factored form of w minus 10 times w plus 7. So coming up here, so w minus 10, w plus 7. Last one. This is like a million little problems in one big problem. So w squared minus 16w plus 63. So let's factor w squared minus 16w plus 63. Okay, so first of all, there's no GCF. A in front of, it's in standard form, ax squared plus bx plus c. A in front of x squared is positive 1. B in front of w is negative 16. C out by itself is 63. So we're looking for two numbers that multiply together to give us a times c. So 1 times 63, which is 63. And the same two numbers to add together to give me b, which is negative 16. 9 and 7 multiply together to give us a positive, means same sign. In order to add together to give us a negative, they both have to be negative. So negative 9 times negative 7 is positive 63. Negative 9 plus negative 7 is negative 16. Thankfully, they've been so nice to us. Our a value is 1, so that means we can use our shortcut. So going straight to our two factors, our variable again is w, and our first blank is w minus 9. So our first factor is w, and our first blank is negative 9. So w minus 9 is our first factor. And our second blank is minus 7. So w minus 7 is our other factor. No GCF to bring down. So we're done. We're going to rewrite w squared minus 16w plus 63 in factored form of w minus 9 times w minus 7. So this is w minus 9 times w minus 7. So now we're multiplying. So I can multiply straight across and put it as one big fraction. So going straight across, let's put it in factored form. So we have our w plus 7 times w minus 7, going straight across, times w minus 10 times w plus 9. And on the bottom, we have w minus 10 going across, times w plus 7 times w minus 9 times w minus 7. So we were able to multiply across and write it as one big fraction. Now we can see what factors cancel out. I'm going to write a little note here just so we know. Again, we're going to multiply straight across. And then let's see now what factors cancel out. So w plus 7 on the top and the bottom, gone. What else? W minus 10 on the top and the bottom, gone. W minus 7 on the top and the bottom, gone. So these aren't exactly the same factors, so those don't cancel. So we're left over with w plus 9 up top. And then on the bottom, w minus 9. They're similar, but they're not exactly the same factor, so our factors cannot cancel here. So we're done. Our final answer is w plus 9 over w minus 9. Remember, we can't cancel out any of these things because that positive is linking it together as one big factor up top. Same thing, this minus is linking w and 9 together as w minus 9 as a factor. These are not the exact same factors, so it can't cancel. We're done. So that was kind of the easier part. And then down here was just all of our work to put it in factored form. All right, so that is multiplying. And then our last page is going to be dividing. So let's divide our rational expressions. Let's start off by dividing and simplifying regular fractions. That way we kind of refresh our memory with dividing fractions. 1/4 divided by 2/3. So it kind of helps me to write this as one big fraction bar. Remember, fraction bars mean divide, so I really have 1/4 divided by 2/3. This helps me see, okay, this is the top fraction, this is the bottom fraction. So now we're dividing fractions. Whenever you divide fractions, we're going to keep the first one the same. We're going to change our operation from division to multiplication, and we're going to flip that last fraction. So we're going to keep, change, flip. Or if you want to say multiply by the reciprocal, or say change, flip, or keep it, change it, flip it, or whatever, however you want to say it, all means the same thing. So however you say it is fine. So the first one we're going to keep the same, so keep it as 1/4. Change our operation from division to multiplication, and now we're going to flip that last fraction. So instead of 2/3, we're going to flip it, and now it's 3/2. So now we're multiplying. So now we're going to multiply straight across. Now we're going to multiply straight across. All right, let's do it. So going across, so 1 times 3 is 3. All over 4 times 2 is 8. 3 and 8 don't have any factors in common, so nothing to cancel out. So it's in simplest form, so we're done. 3 divided by 8. All right, last example for this section. Simplify the following expression. X squared minus 64 all over x squared minus 18x plus 80 divided by x squared plus 7x minus 8 all over x squared minus 6x minus 40. Just like we did on the previous example, let's factor each one separately. So down here, let's factor. our first one, which is x squared minus 64. Looking at x squared minus 64, there's no GCF. This is going to be a difference because we're subtracting two perfect squares. So difference of perfect squares, we're subtracting two perfect squares. So that means we can use our shortcut. Our shortcut says we can go straight to our two factors. X squared is x times x. In order to give us that negative sign, they're going to have different signs. So one's positive, one's negative. 64 is a perfect square. It's 8 times 8. So we factored x squared minus 64 into x plus 8 times x minus 8. So I'm going to write this in factored form up here. X plus 8 times x minus 8. Going across, let's now factor this x squared plus 7x minus 8. It doesn't matter. We're just going to have to factor all of them. So just go for it. So x squared plus 7x minus 8. So factor, that looks terrible. X squared plus 7x minus 8. Our first step in factoring is GCF, but there's nothing that all three terms have in common. So there's no GCF. It is in standard form for us, ax squared plus bx plus c. So a in front of x squared is 1. B in front of x is positive 7. C out by itself is negative 8. So we're looking for two numbers that multiply together to give us a times c, and the same two numbers to add together to give us b. A times c is 1 times negative 8, which is negative 8. B is positive 7. So I'm thinking 8 and negative 1. 8 times negative 1 is negative 8. 8 plus negative 1 is 7. So thankfully our a value here is 1. So we can use our shortcut. Our shortcut says we can go straight to our two factors. Our variable's x, and our first blank is positive 8, so x plus 8 is one factor, and our next blank is negative 1, so x minus 1 is another factor. So we're going to rewrite x squared plus 7x minus 8 in factored form of x plus 8 times x minus 1. So x plus 8 times x minus 1. All right, let's do this one next. X squared minus 18x plus 80. So let's factor x squared. Let me write it down so I can write that. Minus 18x plus 80. Our first step in factoring is GCF, but there's nothing that all three terms have in common, so no GCF. This is in standard form for us, ax squared plus bx plus c. So a in front of x squared is 1, b in front of x is negative 18, c out by itself is 80. So we're looking for two numbers that multiply together to give us a times c, and the same two numbers to add together to give us b. So a times c, so 1 times 80, which is 80, and add together to give us b, which is negative 18. I'm thinking negative 8 and negative 10. Negative 8 times negative 10 is positive 80. Negative 8 plus negative 10 is negative 18. Thankfully, our a value is 1, so we're able to use our shortcut. Our shortcut says we can go straight to our two factors. Our variable is x, and our blank is negative 8 and negative 10. So x minus 8 times x minus 10. So I'm going to rewrite our x squared minus 18x plus 80 in factored form of x minus 8 times x minus 10. Last one, x squared minus 6x minus 40. So let's factor x squared minus 6x minus 40. There's no GCF, nothing that all three terms have in common. This is in standard form of ax squared plus bx plus c. A in front of x squared is positive 1, b in front of x is negative 6, c out by itself is negative 40. So we're looking for two numbers that multiply together to give us a times c, and the same two numbers that add together to give us b. A times c is 1 times negative 40, and b is negative 6. So thankfully here a is 1, so we can use our shortcut. Oh, before we use our shortcut though, I just got ahead of myself because it's like, oh yes, one more. That a is 1. Let's fill in our blanks. So I'm thinking 10 and 4. So negative 10 times positive 4 is negative 40. Negative 10 plus positive 4 is negative 6. So now a is 1, so use our shortcut. So we're going to go straight to our two factors. Our variable is x, and our blank is minus 10. So x minus 10 is one factor. And our other blank is positive 4. So x plus 4 is our other factor. So we're going to rewrite x squared minus 6x minus 40 in factored form of x minus 10 times x plus 4. All right, so all of that work was just to put it in factored form. These are just so tedious, these problems. All right, so we're dividing. So I was going to rewrite it again in factored form, but I don't know if that's really necessary. If you need to write it in factored form, go for it. I'm just going to go ahead and go, okay, we're going to keep the first one the same. We're going to change our operation from division to multiplication, and we're going to flip that last fraction. So keeping the first one the same. So keeping it in factored form of x plus 8 times x minus 8 all over x minus 8 times x minus 10 in factored form. We're going to change our operation from division to multiplication. We're going to flip this last fraction. So before x plus 8 was up top times x minus 1 all over x minus 10 times x plus 4. Let's flip it. So now x minus 10 times x plus 4 is up top all over x plus 8 times x minus 1. Now we're multiplying, so now we can multiply straight across. So multiplying straight across, we're going to get x plus 8 times x minus 8 times x minus 10, times x plus 4 all over x minus 8 times x minus 10, multiplying across, times x plus 8 times x minus 1. So now let's see what factors cancel out. X plus 8's on the top and on the bottom. Those are gone. What else? X minus 8's on the top and the bottom. Those are gone. And then we have x minus 10 on the top and the bottom. Those are gone. There's no other factors in common, so nothing else can cancel. On the top, we're left over with x plus 4. On the bottom, we're left over with x minus 1. These are not the same factors, so nothing can cancel. So we're left with our final answer of x plus 4 over x minus 1. Great, so that is all of Module 7 Homework 1 notes. You can now complete Module 7 Homework 1 assignment. If you have any questions, please let me know. If not, thank you for watching.